Welcome to this video that shows work on refurbishing a Stuart Half Beam engine. The refurbishment was completed in September 2025 but took a long time to complete. I used the project as a fill-in between other projects, and the time taken to complete was lengthened by the number of issues with the engine. These pictures of the engine show it being reasonably well built with some cosmetic issues that needed attention during the rebuild. The engine ran on air during an initial air test, which was a good sign. It wasn't until I started disassembling the engine that I found some serious issues with it. I'll explain some of the issues in the next few clips. The bearing blocks were well out of round, leading to a lot of runout in the crankshaft. I haven't seen bearing blocks as bad as this before. I'm not sure I can attribute the eccentricity to wear either. Additionally, there was a spacer under the inboard bearing block, indicating a mismatch in heights between the sole plate and bearing pedestal. The bearing blocks needed to be replaced with new ones. The top cylinder cover was in two pieces. I haven't seen a Stuart model with this arrangement and suspect there was a problem when the original part was machined. There was no seal between the two parts, which explains the oil on the cover plate. This would have been an area of steam or air leakage while the engine was running. The cover plate was also twice as thick as it should be. The cylinder cover needed to be replaced. The crank web was badly made and worn, and the holes were not aligned with each other. I made a new crank web, which is shown on the top of the photo. I did make a mistake by bushing the crank web, however, the bushing will not affect its operation. Here's a clip of the crank web being rounded in the milling machine. I used a fixture setup that I copied from Blondie Hacks. I'll put a link to her video on the fixture below. I use her technique a lot on my projects. It's a cool tool. The crank pin had been made from brass rod. This wasn't very suitable for the crank pin and was evident by the amount of wear on the pin. Here's a photo of a replacement crank pin that I machined from mild steel. The new crank pin will be much more wear-resistant than the original pin. The beam had been badly drilled and bushed and needed replacing. I learned that this beam was included in a special edition of the half beam, supplied by Stuart Models a while back. I decided to order a new cast iron beam from Stuart. The links surprised me as they were different lengths. One of them was at least 1/8 shorter than the other. These would need replacing during the rebuild of the engine. The valve lifting links had different sized holes in them and were slack on the pins that held them to the valve levers and valve spindle. These would need replacing during the rebuild too. There were a few other parts that needed replacing. These included the crosshead lifting levers, an eccentric rod. These parts looked as though they had been filed to shape. It's possible the engine is built by two different people, as the workmanship in some areas was very good. In other areas it was very poor. By now I knew that there would be considerable work required to bring the engine to a good standard. I had no problem with this, as refurbishing engines is part of my model engineering hobby. So, work started on rebuilding the engine. This photo shows a freshly painted sole plate and pedestal mounted on the baseboard. I ordered and machined a new pedestal casting from Stuart Models. This overcame the height difference between the sole plate and pedestal I mentioned earlier. Here's a photo of various parts after stove enameling. After painting, I let the parts dry for 12 hours and then put them in the oven at 350 F for 25 minutes. This hardens the paint and makes it more durable while rebuilding the engine. I remove any overpaint with a scraper and Scotch-Brite wheel. The steam cylinder was installed on the sole plate and the steam chest test fit on the cylinder. The bearing pedestal was machined to ensure it was level with the sole plate and installed on the baseboard. Next, the beam support and crosshead assembly were installed, along with the steam chest cover. I'll be removing the steam chest cover later to check the travel of the slide valve. I machined a new cylinder cover due to issues with the original cover, as mentioned earlier. The piston rod, top cylinder cover, gland follower, and A-frames were then installed on the cylinder. This photo shows a test fit of the bearing blocks, crankshaft, and connecting rod. I had pinned the crank web I made earlier onto the crankshaft. The test fit went well, and all parts seemed to be turning smoothly. I received a new beam casting from Stuart Models and machined and drilled it to drawing. This photo shows the beam being installed. I had to machine new pins to attach the beam to the piston rod, connecting rod, and beam support. This photo shows the beam installed as well as the eccentric sheave, flywheel, and beam pivot supports installed. I later removed the beam for painting and finishing. I machined a new eccentric rod to replace the brass one shown earlier in the video. This photo shows the eccentric rod installed on the engine. I machined new valve crosshead levers and linkages to replace those shown earlier in the video. This photo shows the parts installed on the engine. With the engine complete, it was time for an air test. After timing the engine, it ran very well. I left the engine running on the bench for a few hours to run in the new parts one had fitted. I'm very happy with how the engine runs. This was a tough restoration to complete as there were many issues with the original engine. It was worth the effort to fix everything though. I'm very happy with the outcome of this project. Thank you for watching this video. Please like and subscribe to support my channel. Thank you.